Faraj, can you see my screen?
Yes, sir, I can see your screen.
Yeah,
It is visible.
yeah, that's okay. So has everyone opened the data? Yeah, so let's proceed further. So as you can see here, we are having a country variable, okay? Then cereal, meat, feed, total cereal. T cereal represent here a total cereal. ln cereal is log of cereal and ln GDP, one is log of GDP. So total cereal consumption, if I can define you for here, so that one is direct cereal consumption plus indirect cereal consumption. So direct cereal, I mean to say when we take cereal in form of rice, chapati, etc. And indirect cereal, I mean here the cereal that we take via consumption of meat. So for production of meat, we require certain amount of cereal to feed animals. So when we convert meat to cereal, okay, and take account into the total, take account for the total cereal consumption, that we call the indirect cereal consumption. So here I have taken a ratio of 1:3. So 1 kg and a production of 1 kg of meat required 3 kg of cereal as a feed. And since cereal consumption varied for different animal, so like for chicken, any consumption of cereal is different. For goat, pig are different. For bovine and other animal are different. So average one is 3 figure. So 3 kg of meat is required to produce, 3 kg of cereal is required to produce 1 kg. If you Google about it, you can get to know more on the subjects and also get the reference reading. But for this econometrics work, as we know, we require one dependent variable and at least one independent variable. So in our case, the dependent variable is total cereal consumption and independent variable one is per capita income. So per capita income is measured here in terms of GDP, in PPP terms, purchasing power parity terms, and base year is 2011 international US dollar. So dependent variable is log of total cereal consumption and independent variable is log of GDP. Time variable that you are having here is year. And we are also having a country code and ID variable. So we required only one, either country code and ID. So here you will be using a country code variable, FAO state country code variable. So, and this data set I have prepared using the World Bank and FAO data set. So in last class, I told you how to merge these two data set. So let's start with the regression. So, of course, I'm not, okay. So for before regression, okay, we require to let this data know you are going to work with the panel data regression. Okay. Even prior to that, sometimes when you need you can say I can say here ki most of the time we can work we work with the balanced panel data instead of unbalanced panel data. So I don't know how many of you are familiar with the panel data regression literature. So there are two categories of panel. One is the balanced panel, other one is the unbalanced panel. So in a balanced panel, we have a data for each country for all the year. And in case of unbalanced panel, we have some missing observation. That means we might do not have some and it do not have some data for some of the country for some years. So that's we call the unbalanced data. Unbalanced data require and working with the balanced panel data is easier than the working with the unbalanced panel data. For working with the unbalanced panel data, you require to know more, a little more sophisticated tools that deal with the unbalanced panel data. So in this lecture, I'm going to focus on to the balanced panel data. So the data set that I have given to you, that is strongly balanced. And when we get to know how the data set is strongly balanced, so when we define your data set as a panel data, at that time a message pop up. It's not that a message display basic, and that where you get to know our data set is a panel data. So I'm doing for that for you. But sometimes we start with the unbalanced data, and it's not a sometimes. It's like always and every time we. It hardly the case that at the beginning we have a balanced data. Initially we do have we have a unbalanced data, and we require to make that data as a balanced data. So for that there is a command that we call the XT balance. So like XT BALANCE, XT balance. This command make your data set as a balanced panel data. So what we do, type XT balance, then range, and you type any range, okay? And of course, that range depend upon your period of study. Let's suppose that if I type 1992 2013, because this particular data set is for 1992 2013, and then I type miss all, okay, and enter, okay. I do not get any message because my data is already balanced. But in the case, if your data is not a balanced data, then this particular command make your data balanced. So period is 90 to 2003 and miss, and then under bracket underscore, all I have written that those, and for those period data set is unbalanced, Stata remove those observations from the data set and make your data as a balanced data. Okay. Sometimes what happen? Okay. I'm leaving that. So this particular command make your data balance. Like the data set that we were earlier using, the meat consumption data and GDP data. So if you have a look onto that, then you can find that meat consumption data having any meat consumption data period one is different from the GDP consumption data. Let me open that one. So clear, huge, meat, this one, and then tab here. So look here, the meat consumption data start with the 1961. And if I open the GDP data for you, then GDP data start with the 1990. And I think we also have a merged data of it. So huge GDP meat. So this one is our merged data. So if I use the earlier command, because now the current data set is unbalanced panel data. So if I use this particular command and keep our period from 1990 to 2013 and enter, then it say you must reset of your data before using XT balance. Okay. So you require to define a year as a time series data. So let's reset year, repeated time value in the sample. Okay, I have to check this one, time variable, panel variable, time variable. Okay. So copy this one and then take away this one. So panel variable is here our country code and time variable is year. Enter. Sorry. Is it why not working?
Sir, actually, I'm getting.
Just a minute. Just a minute. I'll come to you. String variable not allowed IT. Sit. Yeah, look, now it has become. So panel variable is country code FAO. Unbalanced panel, it is showing here. And if I enter the XT balance command here and enter, look here, now the message is coming out. 5,633 observation deleted due to out of range. 1,136 observation due to missing, and 693 observation deleted due to discontinued. Okay, and if I count now, so now you are having only 3,072 observation, and this one is a strongly. And now our data has become strongly balanced panel data. Yeah, someone was asking something.
So I'm getting a error that unrecognized command xt balance.
So in that case, you install XT-Balance first. And for installing the command one is SSC install XT-Balance. Okay, and enter. If computer connected with the internet, this will be installed. So checking, like in my case, it is showing checking XT-Balance consistency and verifying not already installed. All file already exist and are up to date in my case. So install the XT-Balance.
So I have already given the command, but nothing is showing like checking xt balance. It's blank now.
Because he will be using tset command frequently. So anyway, let's move further. So once we have a data, we require to declare our data as a panel data. So after making a data as a balance panel data, we require to declare our data as a panel data, and for that we type, or we may prior to this one xt set, and then you type your country country code variable in our case, and then air, okay, and enter. So look here, is say that panel variable country code is strongly balanced, and time variable is year 1992 2013. Once you make our data as a panel data, okay, first we check for the descriptive statistics, and in case of panel data, for descriptive statistics we type xt sum. So sum give you a summary statistics, and if you enter, you will get a descriptive statistics in this form. So this one is for all the data. So you can also select the variables. So xt set, so not xt set, xt sum, and then since log total serial, log GDP, one is our two variable, you may also add the total serial and GDP. Here that we are using another one. So if you enter all these, you can get a mean, standard deviation, minimum, maximum value. And in a first column, you are getting a, for each variable, we are getting overall, between, within. So overall mean, then overall standard deviation, between standard deviation, within standard deviation, and minimum and maximum value of a particular variable for all these items. So what we need to take out from here, that are, okay, whether you are having a higher variation within the country or between the country. So look, and for that we look onto the standard deviation, and in that you can find here, okay, between variable, for all the variables are higher than the within variation. So standard deviations you can check here. For the log GDP, between it is coming out 0.31, and for within it is coming out 0.08. So between one is higher than within. Similarly, for the log GDP, same is for the total serial consumption, and the same is for the GDP. Okay. So that is the first lesson. Between variation, one is higher than the within variations. And the second lesson that you can learn here from here, or you can say the information that we take out from here, that one is the number of cross-sectional unit and time period. So number of cross-sectional unit is 121 and time period is 24, and total number of observation is 2904. Okay. So these are the two important outcome, or you can say the output that we take out from here.
Sir,
Yeah.
can you explain number of cross-sectional data meaning, like number of cross-sectional time meaning?
Number of cross-sectional unit, I mean to say number of country here. Number of country here. Yeah, small I.
Okay. Oh, small n.
Small n, right.
Okay.
Yeah, so okay, so this one is our summary statistics. Now let's move
Can
further.
we copy this output to our MS Word file or Excel file?
Yeah, that you can do. Just copy it and paste there. So it's copy from here. So copy as a table, and then you can take it to the Excel.
Okay, sir.
Okay. So this one is our summary statistics. Now let's move further, and now we are going to estimate pooled regression model. So for pooled, we just type regress, so REG, and then dependent variable, which one is the log of total serial, and then independent variable, and log of GDP in our case is the independent variable, and enter. Okay. So this one is pooled regression result. And here you can see the coefficient value of log GDP is statistically significant at 1% level of significance. Coefficient value, intercept is also statistically significant. R square that is coming out here, that is 0.59. So if you round up that, then 0.60. That means 60% of variation in total serial consumptions. Okay, log of total serial consumptions explained by log of GDP, and we are also getting the rest of the statistics. So this one is the pooled regression model. The problem with this particular regression model is that if regression model suffer with the endogeneity problem, okay, and which likely the case in this particular regression model, then we get biased and inconsistent estimates. Okay. Again, I am repeating, if regression model suffer with the endogeneity problem, then from the pooled regression result, we get biased and inconsistent estimates. The second one is, even though regression model does not suffer with the endogeneity problem, but if there is a presence of unobserved cross-sectional heterogeneity, then in that case, pooled regression model give us the inefficient result. If the latter is the case, then random effect model give us the best result.
Can you repeat?
The second one.
Yeah.
I'm saying even though the regression model does not suffer with the endogeneity problem, but if there is a presence of unobserved cross-sectional heterogeneity, then pooled regression give us the inefficient estimates of the parameter.
Sir, how do we know that there is unobserved cross-sectional heterogeneity?
Later we'll check. So when you do the diagnosis test, and you will check, there is a test for the unobserved cross-sectional heterogeneity that we will do later. Yeah. A general idea that we get from the descriptive statistics, so, and that I have shown you here, between variation, one is higher than the within variation. Okay, and that is an indication of cross-sectional heterogeneity, but later we will do a proper test for it. So I was saying that in presence of unobserved cross-sectional heterogeneity, pooled regression results give us the inefficient result. In that case, we use random effect model. If first is the case, that means if there is an endogeneity problem, in that case, both pooled regression result and the random effect model give us the biased and inconsistent estimates. So in that case, fixed effect model gave us the best result. So in that case, we use the fixed effect model.
Sir, please repeat it again.
So I'm saying if there is an endogeneity problem, in that case, both pooled regression and random effect model give us the incorrect result. That means the result that we get that are biased and inconsistent. So with the in case of endogeneity, fixed effect model give us the correct result.
If there is presence of unobserved cross-sectional heterogeneity, then which model?
Right. If there is a no, listen full statement. I'm saying if there is a no endogeneity problem. So in absence of endogeneity problem, okay. If there is a no endogeneity problem, but if there is a cross-sectional heterogeneity, in that case, pooled result give us the inefficient result, and random effect model give us the efficient result. If there is a endogeneity problem, then in that case, both pooled and random effect model give us the incorrect results. Pooled result give us the best result only in a case when there is no unobserved cross-sectional heterogeneity, and along with there is no endogeneity problem. No unobserved cross-sectional heterogeneity and no endogeneity problem. So wherever I say cross-sectional heterogeneity, okay, and relate that with the endogeneity, read that is unobserved cross-sectional heterogeneity, not simply heterogeneity. That is unobserved cross-sectional heterogeneity. So in absence of unobserved cross-sectional heterogeneity and in absence of endogeneity problem, pooled regression result give us the best result.
Which result? Which regression result? Pooled.
Pooled, yeah, this particular regression. So when I say all assumption of linear regression model satisfy, then in that case OLS give us the best result. So pooled regression is in pooled regression, basically we are using the OLS technique. So OLS gives us the best result. One more, and that is the implicit assumptions when we estimate pooled regression model. And in that assumptions, we assume that each observation is independent from the other observation. So that one is the identically independently distributed. So so that means one observation is independent from the other observation. So, but with the panel data regression model, it is hardly the case, and generally we can see the violation of this assumption, implicit assumption. I'm not covering why pooled OLS regression result gave us the inefficient result. That is because of autocorrelation problem. Okay, but why I know what way that autocorrelation is arising here, that I am not covering. Because if I go to that because that is the part of the econometric theory that takes a time, and probably the practice, and we have to compromise with the practical part of the panel data regression model. So let's learn practical part, and later when we do this exercise, try to have a simultaneously look onto the theory also, because it is the theory from where we get an idea why you are doing that particular things, why you are running using a random effect instead of pooled, when we have to make a selection of the pool. So there is a poolability test also. Through the poolability test, basically we decide between the random effect and pooled regression results. Okay, there is a presence of random effect also. So in that case, we decide whether you can use a random effect model or pooled regression results. Okay, for fixed effect, and there is a Hobson test, and also there are some other criteria that help us to deciding whether you can use fixed effect or random effect. But anyway, we can talk about all those in a brief when we estimate fixed effect or make a choice between any fixed effect and a random effect. So let's proceed further. I think I'm making my point clear. So shall I proceed further?
Yes, sir.
Yes, sir.
Yeah, that's fine. So this one is a pool regression result. There is a command for checking heterogeneity across country and over period of time. That I am not doing. I'll share my do file with you. You can copy the command from there and check the cross section and heterogeneity across country and over period of time. In that do file, there is also a command for checking autocorrelation, given because of presence of autocorrelations, pooled regression result give us the inefficient results. Okay, so again I am not doing that. The next model for us is the fixed effect least squared dummy variable regression model. So for fixed effect least squared dummy variable regressions, we use dummy variable for each cross-sectional unit, and so for that what we type xi and then the same regression ln total serial, then ln GDP, and then we type I, comma, our country code variable. So country code, I dot country code, and enter. Remember, in a pooled regression model, I haven't done any diagnosis testing. So I'm assuming that we know all the diagnosis testings of linear regression model. So in a case if pooled regression model is your final regression, then after then you're required to do the diagnosis testing also. So the next line of command is for the fixed effect least square dummy variable regression model. And if I enter, we can see here, we got the result. So LNGTP is the coefficient value. LNGTP is our independent variable, and the coefficient value of LNGTP is 0.144. R square in this case is 0.95, and also almost all countries damage coefficient values are statistically significant. So that means every country is significantly different from the other country, of course, in terms of serial consumption. So serial consumption for each of the total serial consumption for each of the country is significantly different from the base country. Base country, one is here. The one country has become a base country. So and other countries serial consumptions are comparing to that base country, and again we find a significant difference for all country to the base country. So this one is the fixed effect least square dummy variable regression result. Again, I'm not going to do any kind of diagnosis for it. The lesson that we require to get from here, that one is the significance of the country's dummy and the significance of the log GDP variable. R square is hardly matter here since we have used around 120 dummy. So look here, the R square goes up to 0.95. Okay, so we know the rule of it is one of the rule of maximizing R square. If you keep adding variable to your model, we keep getting higher and higher value of R square, and the same what we are getting here. Okay, so all dummies together along with the coefficient along with the GDP together determining around 95% variations in the total cereal consumptions. So that we can say, but I think someone had a doubt regarding it. He messaged me yesterday. Yeah.
Yes, sir. But the same query, how to deal that if I have 70 companies covered under 15 industries, so I want to check the impact of industry-wise, like fixed effect dummy variable industry-wise instead of the company.
Yes.
So how to do that?
So you generate a variable, okay, from variable, okay, an industry-wise variable. So industry-wise dummy you can say. So let's suppose that you are saying we are having a 15 industry.
70, yeah, 15 industries.
15 industry and 70 firms.
Yes, sir.
So so in that case, probably if you go to the average formula, then one industry approximately having a 5 firm. Okay, on around having a 5 firm, you can say.
Okay.
So for those 5 firm, you generate a